In a groundbreaking discovery, NASA's James Webb Space Telescope has uncovered compelling evidence of a colossal planet orbiting Alpha Centauri A, the closest solar twin to our Sun, just 4 light-years away. This stellar system, a trio of stars, has long been a prime target in the quest for exoplanets. Alpha Centauri, nestled in the southern sky, comprises Alpha Centauri A and B, both akin to our Sun, and the dim red dwarf, Proxima Centauri. While Proxima Centauri hosts 3 confirmed planets, the existence of others around its companions has remained elusive. Webb's mid-infrared instrument, MIRI, has provided the most robust evidence to date of a gas giant circling Alpha Centauri A. The findings are detailed in a pair of papers accepted by the Astrophysical Journal Letters. If verified, this planet would be the nearest to Earth, orbiting within the habitable zone of a Sun-like star. However, its gaseous nature suggests it cannot support life as we know it. Given the proximity of this system to us, any discovered exoplanets would offer unparalleled opportunities to gather data on planetary systems beyond our own, explains Charles Beichmann, co-first author of the papers and a researcher at NASA's Jet Propulsion Laboratory, and the NASA Exoplanet Science Institute at Caltech's IPAC. Observing these stars is a formidable task, even for Webb, due to their brightness, proximity, and rapid movement across the sky. Webb was designed to detect the most distant galaxies, and the custom observing sequence developed for this target by the Space Telescope Science Institute has proven spectacularly successful. Through meticulous planning, analysis, and modeling, the team determined that the object seen in Webb's image is likely a planet, not a background galaxy, a passing asteroid, or an image artifact. The first observations, conducted in August 2024 using MIRI's coronagraphic mask, revealed an object over 10,000 times dimmer than Alpha Centauri A, at a distance roughly twice that between Earth and the Sun. Despite the challenge posed by Alpha Centauri B's brightness, the team managed to subtract the light from both stars, uncovering the faint object. The initial detection was thrilling, but additional observations in February and April 2025 did not yield any objects similar to the one identified earlier. We're faced with a vanishing planet. To solve this enigma, we employed computer models to simulate millions of potential orbits, factoring in when we observed the planet and when we didn't, says Aniket Sanghi, a PhD student at Caltech and co-first author of the papers. The simulations considered a 2019 sighting by the European Southern Observatory's Very Large Telescope, Webb's new data, and orbits stable in the presence of Alpha Centauri B. Researchers note that the lack of detection in subsequent observations isn't unexpected. In half of the simulated orbits, the planet moved too close to the star to be visible to Webb in February and April 2025. Sanghi explains, based on the planet's brightness in mid-infrared observations and orbit simulations, it could be a Saturn mass gas giant orbiting Alpha Centauri A in an elliptical path, varying between 1 to 2 times the Earth-Sun distance. If confirmed, the potential planet in the Webb image of Alpha Centauri A would set a new benchmark for exoplanet imaging, Sanghi remarks. It would be the closest to its star among all directly imaged planets, with temperatures and age similar to our solar system's giant planets and the nearest to Earth. Its existence in a dual star system would challenge our understanding of planetary formation, survival, and evolution in chaotic environments. Confirmation of the team's findings could revolutionize exoplanet science. This would become a cornerstone object for exoplanet studies, offering multiple chances for detailed analysis by Webb and other observatories. Beichmann states, NASA's Nancy Grace Roman Space Telescope, set to launch by May 2027, will complement Webb's infrared observations with visible light data, providing unique insights into the planet's size and reflectivity. The James Webb Space Telescope, an international collaboration led by NASA with ESA and CSA, is the world's premier space science observatory, unraveling mysteries in our solar system, exploring distant worlds, and probing the universe's origins. For more information, visit https://science.nasa.gov/web.